All right, what up, everybody? This is assignment 3.4. There is no assignment 3.3. I think that lesson was skipped over or something, but we are moving on with assignment 3.4, which is division. And we are going to accomplish these problems with a method called synthetic division. Synthetic division. I'm not exactly sure if we're going to actually get into long division, but we are going to be using synthetic division here. So what we're going to be doing is we are going to be dividing. Okay, let's quickly learn how to set up these divisions. Okay, as is right now, what I notice about what I'm dividing by is a singular x and then some number, some constant. All right, and that's really what you're looking for, is some number and a constant. It gets really confusing when you start having like x squareds and things like that in there. It makes the process way more difficult. However, there are two confusing problems in this assignment, and I believe that's numbers 8 and 9 on this assignment. We'll obviously talk about them. But yeah, so what we're really trying to do is we're trying to avoid what we're dividing by, the bottom number, to be an x squared. So this is a straight up x and a number, so this is pretty much built for synthetic division. All right, what the heck is synthetic division and how do I do it? Okay, the numerator, this number right here. What we do is we write that numerator beginning with the largest exponent. So here we have x squared x normal number. And what we do is in synthetic division, we write down purely the coefficient, aka the number next to that thing, going all the way down to the normal number. So my x squared is 1, my x is a positive 7, and the normal number is negative 2. So I start to set up my problem beginning with the largest coefficient. So relating this to number 2, the numerator, again, it begins with an x squared, so that would be 3, 9, and 1. 3, 9, and 1. That is the numerator. That is what I'm dividing. Okay, now, again, we'll talk about that just a little bit. Actually, no, let me jump to a problem in which that will become a little bit more confusing. That confusing. I guess as good as any, I guess. All right, so the top number in number 3 starts with an x to the third, and that would be 1. Sorry, marker here. 1, 6, negative 5, and positive 20. Okay. Now, in number 4. Okay, notice how the largest exponent is an x to the 4th. Okay, now regardless of if one of these letters are there or not, it has to be represented. So if this problem begins with an x to the 4th, I have to go all the way down to the normal number. I can't miss one of the variables, even if it's there or not. So for instance, the number that is next to the x to the 4th in this problem is 4. There is no x to the third, so technically there's a 0 next to it. There is no x squared, so technically there's a 0 next to it. There is no x, so again, technically there's a 0. And the normal number is positive 5. So what you do is you have to be on the lookout when you set up this number that all of the x's are represented from the biggest exponent all the way down to the normal number. And if something doesn't exist, you fill in the missing part with a 0. All right, so we learned how to set up that portion of the problem. Then what we do is we construct this L-looking shape, okay? And we leave like room right here because we're going to be writing numbers in here. So we leave a little space and we make this L-looking shape. Okay, now what we're going to be dividing by, this x minus 2, is represented by a number that I write right here. Okay, kind of in line with it, I write it on this outside of this L-looking shape on the outside. And what it is simplistically, it's the opposite of whatever that number is. So if this number is -2, it's +2. Okay, it's what would make this thing equal to 0. What would make x minus 2 equal to 0? X would have to be +2. So the number +2 goes on the outside. All right, so example, in number 2, the number that goes on the outside, I see that it's an x plus 3, so it'll be a -3. All right, so now we have our framework of the synthetic division. Okay, now we're set up to actually do the division itself. Now, luckily for us, I don't know about you, but division is not my strong suit. I have a difficult time. I can multiply real quickly, I can add and subtract real quickly, but division is probably my weakest operator that there is to deal with. So luckily, there is no division in synthetic division. It's actually pretty basic. All right. So the first thing that you do is you drop down this number and you write it underneath. So that number automatically gets a pass. So I drop the very first number, right? So in the second one, I automatically drop this 3. It automatically gets below that line. Okay, so you drop that first number, whatever it is. And then what you do is with this outside number, you multiply this bottom number. You multiply whatever that bottom number is. So here, the bottom number is 1, so I go 2 times 1. 2 times 1 is 2. And you write that number up below this next part. So 2 times 1 is 2, and so I write in 2. So for example, number 2, the outside is, so I have -3 and +3, so this is going to be -9. Okay, so you multiply the outside, and then what you do is you add these inside numbers. You add the inside numbers, and that creates another outside number. So here, 7 plus 2 is 9. In number 2, 9 plus -9 is 0. So I multiply the outside and I add the inside, and then I repeat the process. So now I have 2 times 9. 2 times 9. You always use that outside number, so this is going to be 18. So here I have -3 times 0. And then again, you add these insides. So -2 plus 18 is 16. 1 plus 0 is 1. And that's the process of synthetic division. So you drop that first number, you multiply all these outside numbers, and you add all these inside numbers as you go along. You multiply the outsides, and you add the insides. Now, what is my answer? Okay, what is my answer? If this original problem began with an x squared, the answer, which is on this outside, is 1 less of that. So if that's an x squared, this answer is an x. Okay, that answer is an x. And then you digress. This is a positive 9, nothing. And then this remainder, what you do is you write it as a fraction over what you were originally dividing by, which in this case is x minus 2. And so that's your answer. So my answer is 1x, or aka x, plus 9 plus 16 over x minus 2. So in this one, this original first number was an x squared. So my answer is going to be 3x, okay, technically plus 0. We don't write that in there. Plus 0 plus 1 over x plus 3. We don't write the plus 0. So my answer is 3x plus 1 over x plus 3. So you write down the numbers. That outside number is opposite of what you're dividing by. So in number 1, it was minus 2, so it's a plus 2. In number 2, it's a plus 3, thus it's a minus 3. You drop the first number, you multiply these outside numbers, and you add the inside numbers. So let's take this problem from scratch. All right, so I see the number that I'm dividing by is, in essence, a 1, 6, negative 5, positive 20. I'm dividing by an x minus 2. An x minus 2, so it's going to be a positive 2. I drop this first number, and I multiply the outsides, which is 2 times 1. 2 times 1 is 2. Okay, and then I add the insides. 6 plus 2 is 8. I multiply the outsides. 2 times 8. I add the insides. Negative 5 plus 16. I multiply the outsides. 2 times 11. I add the insides. 20 plus 22. Okay, so I ran through the entire process. This original problem was an x to the third, so my answer begins with an x squared. So my answer is 1x squared plus 8x plus 11, right, plus 42 over x minus 2, what I was originally dividing by. Okay, so I again was mentioning how you can't have missing pieces. So if I begin this problem, this is a 4x to the fourth. All right, and so I have to represent the x to the third. So this is my x to the fourth. I have to represent the x to the third, x squared, x, and normal number, whether they exist or not. So I have 0, 0, 0, and 5 in this particular case, because I don't have an x to the third, an x squared, or an x. I have an x to the fourth, and I have a normal number, but I don't have any of those others. So those things are represented by a 0. I'm dividing by x plus 1, so that means a minus 1 goes on the outside. I drop the first number, and I multiply outsides. Negative 1 times 4 is negative 4. I add. 0 plus negative 4 is negative 4. I multiply. Negative 1 times negative 4 is positive 4. And then I add. 0 plus 4 is 4. And then I multiply. Negative 1 times 4 is negative 4. And then I add. 0 plus negative 4 is negative 4. And then I multiply. Negative 1 times negative 4 is positive 4. And then I add. 5 plus 4 is 9. this original problem began with an x to the fourth, that means my answer is going to begin with an x to the third. So that is a 4x to the third minus 4x squared plus 4x minus 4 plus 9 over x plus 1. So again, the long story short is you multiply these outside numbers and you add these inside numbers. All right, so again, number 8 and number 9 are pretty confusing. So those are the next hard problems. Everything else is pretty much the same problem. Just keep doing it and doing it. So here we go. Let's kind of kick it into high gear just for a second. So we got 3, just a little bit. So we have x to the third, x squared, x, normal number. I'm dividing by a x plus 4, so that would be a minus 4. I drop, I multiply, add, multiply, add, multiply, add, such. And then my original problem began with an x to the third, so my first answer is an x squared. Oh, even though this last number is a negative, notice how I always represent it as a plus. Okay, I always represent this last bit as a plus, and if it's a negative, so be it. I'll just put that inside the fraction itself. For that last number, I always represent it as a plus. And then if it's a negative like it is here, I just put the negative on the inside of that fraction. So no missing pieces. So this is a 3, 6, negative 5, 20. So it's not missing any of the letters. Dividing by an x plus 5, so that's going to be a minus 5 on the out. Drop the first number, multiply, add, multiply, add, multiply, negative 200, add, such. The original number was an x to the third, so my first answer is going to be an x squared. Here we have a 1, negative 5, 4. X minus 1 is an x plus 1, positive 1. Drop, multiply, add, ooh, 0. That's cool. So my original number was an x squared, so that is going to be a 1x, or you can just write x. 1x and x are the same thing. Minus 4, and then technically this would be a plus 0 over x minus 1, but again, that's a 0, so we don't bother writing it, and so that's your straight answer. Okay, now, as I said, number 8 is a little bit more difficult than the other problems, and here's why. Notice with what we're usually dividing by. We're usually dividing by something like x minus 1. Or in some of the other examples, we had x plus 5 and x plus 4. Okay, we're dividing by very simple singular number, singular letter number things. Now, in number 8, however, Notice what we're dividing by. We're dividing by a 2x plus 3, which makes the process just a little bit more difficult. Now, so when I'm dividing in synthetic division, why am I choosing +1, -5, and -4 for these things? How do I come up with that number? Well, technically what I'm doing is this. When I have an x minus 1, technically what I'm asking myself and what I'm doing is I'm setting it equal to 0. And so if I do that, what is x equal to? So I would have to add 1 to both sides, and then huzzah, x is equal to +1. That's technically what I'm doing. So in here, if I set that x plus 5 equal to 0, I have to minus 5 from both sides, and that makes x equal to -5. Same with right here, set it equal to 0, -4. Thus, the x is -4, and that's the number that I use on the outside. Okay, well, what number would I use on the outside in number 8? Okay, so I'll repeat the process. I'll set that technically equal to 0. So solving this, I would subtract 3. So that leaves me with 2x is equal to -3. And then I would divide by 2. So I end up with -3/2. What I usually say, it's opposite number over letter. Opposite number over letter. So the number is 3, so it's opposite the number, -3, over the letter, which is 2. That's my simplistic way of solving that pretty quickly. All right, so anyways, -3/2 is that outside thing that you're going to have to be using. Okay, so what you can do is you can set what you're dividing by equal to 0 and see what that x is equal to. Now, a reminder how to handle fractions. Top numbers multiply, bottom numbers divide. Top numbers multiply, bottom numbers divide. Right, I have to get rid of some of this stuff so I can fit in the work here. All right, so here we go. Let's put this all together. So the number that I'm dividing is 6, 1, and -7. Okay, the x is technically equal to -3/2. Top numbers multiply, bottom numbers divide. Keep that in mind. I drop the first number, 6. So I have to multiply this stuff. So 6 times -3/2. That's the first math problem. 6 times -3/2. All right, I'm going to go with the division first. I'm going to go and I'm going to divide and then multiply. So 6 divided by 2 is 3. 3 times -3 is -9. You can do it the other way around. You can multiply and then divide, but I think it's a little bit more simple this way. So I divided and then multiplied, which is totally legit. So 6 divided by 2. 6 divided by 2 is 3. 3 times -3 is -9. As long as you multiply the top number and divide the bottom number. Okay, so that came out to be -9. So that multiplication came out to be -9. So I multiply the outsides, I add the insides. So +1 and -9 is -8. So again, here is my next math problem. I have to multiply these outsides. So I have -8 with -3/2. Okay, I'll divide, so that comes out to be -4, and then I'll multiply, which is +12. I divide the bottom, and multiply the top. So that comes out to be positive 12. And then I add. So my original problem began with an x squared, so this is going to be an x. Okay, one less of where it began. Minus 8 plus 5 over what I was originally dividing by, which is 2x plus 3. Okay, number 9 is also the other really tricky question in here. And the reason that this is tricky, again, is what we're dividing by. Technically, what we're usually used to is an x plus 3 or something like that. And then thus I would use negative 3. Or the one that I just looked at, 2x minus 5. Opposite number over letter. It'd be 5 over 2 or something like that. Pretty basic. In this problem, notice how we have an x squared. All right. So this makes this problem a bit more difficult, quite a bit more difficult, actually. All right, but luckily for us, x minus 4 is the same thing as saying x plus 2, x minus 2. It's a difference of squares. X plus 2, x minus 2. And that is awesome. So what I'm going to do is I'm going to take my number and I'm going to divide by both of them. One at a time. One at a time. All right. So I set up the number that I'm going to be dividing. So I start with an x to the 5th. X to the 4th. Notice how it does not have an x to the 4th. X to the 3rd. X squared. X. And then normal number. Okay. Now, what I'm going to be dividing by, I'll just choose this first one first, this x plus 2. That means the first number that I'm going to be using is negative 2. I'll write this a little bit smaller. It's going to be more work than the average problem. All right. So I'm going to take care of that first one first, that x plus 2. All right, so 1. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Okay. Take note that this is the first remainder right now. Just take note of that. So right now there's one remainder. Okay. So as I said, I'm going to do this twice. So with my answer that I have, I'm going to set up the second one, which would be technically a positive 2. And I'm going to repeat this process with the answer. So I multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so now if there was one remainder before, now there's 2 remainders. And I'll show you how to handle that. Okay, so the original problem was an x to the 5th. That means this first answer technically would be an x to the 4th. This answer is an x to the 3rd. Okay, so my answer begins with an x to the 3rd. So it's 1x to the 3rd plus 0x squared plus 10x plus 0. Okay, plus the remainder. And what I kind of do is I kind of work backwards. So if I have two remainders, the first, I begin with a normal number and I work backwards. So x, x squared, et cetera, et cetera, et cetera. And so because there's two remainders, that's going to be a normal number and an x. So this is going to be 40x plus 2. 40x plus 2 over what I was originally dividing by, which is an x squared plus 4. We probably won't see too many of those. It might rear its head every once in a while, and I'll try to give you the heads up on if it's there or not. All right, here we go. Last one is easy. So the general process is 2, 1, negative 1. X plus 4 means a minus 4. Drop the first, multiply, add, multiply, add. The original problem was an x squared, so our first answer is going to be an x. So that's 2x minus 7 plus the remainder. That is